Imagine a scenario where you walk into your favorite department store. You just got a bonus at work, so you got a little extra cash in your pocket, and you're finding all kinds of things that you want to buy. So you take these items into the dressing room, and you begin to try them on. The things that you really like, you put in one pile. The things that you don't like, or maybe they don't fit, you sit those in another pile. And the ones that you're undecided about go into a third pile. Now, imagine the mirror in the dressing room has been watching these actions and is now able to recommend to you other items in the store that you might like based on the patterns that it observed. Not only that, but the mirror also has these cute little buttons that you can press for their recommendations that will send an alert out to the store clerk, and they'll bring those items to you if you want to try them on. Sounds cool, right? Yeah. So this scenario was imagined by a friend of mine, Lisa DeLuca, an IBM distinguished engineer. And what's really cool about this is that this solution can actually exist today. The technology is already there. So my question to you is, how would you test this? Take a moment, think about it. Do you even know where to begin? This will be my question to you for the remainder of our time here. Now, there's a lot of smart, fantastic people who are talking about artificial intelligence and the future of testing. People who I admire, people who I respect. People like my good friend Paul Merrill, who says machine learning won't necessarily eliminate testing jobs, but it will change how the work gets done. The World Quality Report says we believe that the most important solution to overcome increasing testing challenges will be the emerging introduction of machine-based intelligence. And the good folks over at Applitools, they say we'll see a trend where humans will have less and less mechanical dirty work to do with implementing, executing, and analyzing test results, but they will still be an integral and necessary part of the test process to approve and act on the findings. Now, this all sounds great to me. I can't wait for the day when we have testing tools that help us do our jobs better. But there's a little nagging voice in my ear, I believe it's the tester inside of me, that's saying, but who's testing it? How do we know that it works, right? Developers, testers, product people, everyone is just saying, oh, that part of the application we're using machine learning, so don't worry about testing it. I call BS on that, especially because we're seeing machine learning and things like this being used more and more every day in our everyday technologies, right? Such as Netflix. How many people use Netflix? Yes, lots of people, right? Did you know that when you launch Netflix, on that first page, this page is made just for you, courtesy of machine learning, right? So these are all recommendations that Netflix thinks that you would want to see. Now, 80% of what we watch on Netflix comes from recommendations. So this is pretty important to their business model that they get this right. How do you test this? Now, I know myself better than anyone else, but I can't even say if my Netflix page is right or wrong. I don't know why those recommendations are there. I took a closer look at it to see if I could see anything that looked wrong. The only thing I could really come up with was this Beyond Stranger Things. Anybody watch Stranger Things? A couple of people. So it's an American show. Someone is very enthusiastically letting me know that they watch this. So this is an American show. It's very popular in the States. I don't watch it, though. I've never seen a single episode. So I was like, what is this Beyond Stranger Things? I went out to Google, I searched, and Google let me know that this was a show that's like a after show to Stranger Things, and they basically discuss the episodes. And there was a disclaimer. If you haven't seen Stranger Things, then you probably shouldn't watch this. Well, I hadn't, so this seems like a bug, but is it? I don't know. I don't know why Netflix recommended this to me. Twitter. So we use machine learning for quite a few things at Twitter, one being to detect spam. How would you test something like that? Let's look at this tweet, for example. It says, message us if you're looking to buy some followers, $2 per 1K. Seems like spam, right? But how do we know this is spam? Maybe by some of the keywords. But then we have a tweet like this. Hey, wannabe celeb, you have a total of 2K fans. Why don't you go buy some followers? Rude, but not spam, right? So how would you test something like this? Very difficult question. IBM, they have Watson, which is their artificial intelligence platform. And specifically, they use it for this one initiative, a health initiative, where given a cancer patient, IBM Watson can analyze millions of records of medical data, as well as clinical trials, and be able to come up with a personalized treatment plan for a patient. How do you test this? This definitely seems like something that we don't want to get wrong, right? Right. So I can sit here for the next few minutes and give you a whole bunch of theory about machine learning and tell you all about the algorithms and yada, yada, yada. It's not really my lane, okay? So I work in the trenches. I think that I provide value when I give you my stories based on things that I've actually done. And fortunately, I have actually tested machine learning applications. So is it cool if I share my experience with you all? Yes. Great, thank you. All right, so once upon a time, I worked on an application that was essentially an advertisement recommendation system. And the way this worked is third-party applications, businesses, commerce-type businesses, could give us their inventory of ads. We would then store those ads, and then when that business was working with one of their customers in real time, they could make a call, service call, to our application and basically say, this is who I have. And it would be maybe a customer ID along with some demographics. So this is a female who's 21 years old. Based on that information, our service would give them the best ad to show from their inventory. Okay, of all the ads that you have, this is the best one to show that person, right? What was the secret ingredient here was the machine learning piece. So we had machine learning, and it was supposed to continuously learn what were people buying based on the ads and based on their demographics. So we would get better and better over time, and e-commerce sites' conversion rate would get better over time as well. So I had to finally answer this question of how would you test this? Because I was tasked to not only test but automate some scenarios around this, right? So I didn't even know where to begin. At that time, I hadn't even heard of machine learning before. So this was all very new to me. I began to do some research and learn about machine learning, AI. However, there was nothing there in the literature that told me how to test this stuff. So I had to come up with my own plan of attack, and that's what I'm going to share with you today. The very first thing that I needed to do was learn how it learns. I believe that the reason that we could not answer the questions before in the presentation about Netflix and Twitter and these things is because we don't know how it's actually learning and making the decisions that it is. So that's the first thing I needed to do. So I began reading some docs about it in my company. I began talking with the developer. There was a subject matter expert that worked on this. He was the resident expert on machine learning in the company. And so I began to have conversations with him about the product. Also, this guy, he was really, really smart, right? So he knew this stuff. He was very much so the opposite of me, the theory guy, right? So he would give me like a bunch of mumbo jumbo that was kind of like in one ear and out the other. So I even went into the code base and started looking at that. Again, over my head. And I have a master's degree in computer science, but this stuff was very complicated, right? So I did the best I could so that I could try to understand what it is that we have here, what it is that we're building, what are we expecting, right? One thing that I learned is that there was no exact expectation. And that was troubling to me as someone who's worked in the testing space, because I grew up on the rule that if something was not predictable, the outcome wasn't predictable, you didn't test that. You left that alone, right? Especially from an automation standpoint. So looking at a scenario like, hey, we place an item in the cart, the item costs $30. If we increase the quantity to 3, the subtotal is 90, right? Exact, testable, automatable. But not so much with this. No one could really tell me what would be the outcome. Instead, it might be a range of validity. So that was interesting to me. Also, I learned that the system would create models based on what it learned. And so these models would be what the system would consult to make its future decisions, and these models would be constantly updated as it learned more. Now, if there were no models, meaning the system hadn't learned anything yet, then it would just randomly send ads to the users. All right? So once I learned that much, I said, okay, now I need to train the system. So I need to do something so that it can create these models. So I created an automation script that would essentially make these calls out to our service. And another thing that I learned is that the more data that it had, the better it could learn. So I said, okay, let me do a bunch of service calls out with different customers and help it learn this data. And I would give it a couple of ads to kind of learn from, right? So I did 2,000 web service calls with unique customer IDs, so everyone was unique. And this was programmatically, so all of the IDs were just generated. And then the scenario that I wanted to give it, I wanted to train the system that men would prefer to buy pants and women would prefer to buy dresses. So I randomly generated the gender of each of the customers, also in the code. And so either specific gender, it would be 50% of that. There were 5 ads, the pants, the dress, and then 3 other items of clothing. And so initially, 20% of those should be shown. And then there was another service call that the third party would need to make. So I needed to do that in my code. That service call would be, once you send it to the customer, did they act on it? Did they actually buy this? Did they accept it? If so, that was another service call that went back. So initially, I started setting it up where, okay, anytime that the gender was a male and they were served the pants ad, then they would accept it. Vice versa for the women in the dress. But I thought about this, and this wasn't a really realistic scenario with 100% acceptance rate, and so I didn't want a scenario where it only works if 100% acceptance. So I scaled that down to 65%. So 65% of the time, a woman got a dress ad, she would accept it. All right? And then 2% of the time, no matter the gender, no matter the ad, I would accept because I wanted to create models for each of the 5 ads. All right? Okay, that's the math part. So I had to create a complex data structure to hold all of this information. So as I was sending the request and people were accepting it, I captured all of this information. And this is what it sort of resembled. So as you can see, we have the first column. This is the different types of ads. And then the second column is the women who saw. So you see that each one of those is about 200, so that fits the whole random theory. And then I had 133 of the 202 women who were served the dress ad actually go ahead and purchase the ad. All the rest, 3 or less. For the men, 196 were served the pants, 128 accepted. Everything else, 3 or less, right? Cool. So I had all of this set up, feeling kind of good. And then I thought, well, how am I supposed to test this? Like, what's the assertion that I write here? How do I know what's expected to come back? And again, there was no exact answer, but I went and asked around, okay, well, what's the range? No one could give me this information. So this became a little more complicated, and I decided that I would use the POX method. The POX method is plain old common sense. That's all I had, right? So if before the system learned they were serving the ads 20% of the time, then after it learned, the dress should be shown to the women more than 20% of the time, the pants should be served to the men more than 20% of the time, and all others should be less than 20% of the time. That's all I had. I went with it. We'll figure out the rest later. So I went ahead and I ran 2,000 more queries. New customers, male, female. And then this is the data that I got back. So before learning, 202 women saw the dress. After learning, 890 saw the dress. Yay, wonderful, looks great. Looked at the men, 196 saw the trousers before learning, but then only 59 saw after learning. So I was like, okay, that's not right. And then I looked at the men who saw the dress. 874 men were given the dress. So I began to wonder, what did I do wrong? I started kicking myself and doubting what I'd done, and I don't know anything about machine learning. I don't know why they asked me to test this stuff in the first place. So automation engineers, we love a good retry, right? So I tried it again. Threw all the models out, ran the scenario again. Something different happened this time, though. This time, the men did see the pants ad more than 20% of the time, but so did the women. And then they both didn't see the dress ad very much. So I was like, what is going on here? I started looking at my code. I went through it line by line, trying to figure out, what did I goof up here? I couldn't find the error. Wiped it all out. I said, hey, they told me that the thing learns when it has more data. Maybe 2,000 was enough. Let's crank it up to 10,000, right? So I did 10,000 customers, ran it again. Same thing. So it kept flip-flopping between the dress being the most popular and the pants being the most popular. So I began to analyze those data structures that I had in my code and the results that were there from each run and began to compare them. So what I found is whichever ad was purchased the most, was accepted the most, that was the most favorable ad. So it was learning, but not on the demographic. So it wasn't learning on gender. So I said, I found a bug. Wonderful, I'm doing my job. I know what I'm doing. Now, writing this bug was different than any other bug I've ever written in my life, right? So I'm used to, I write a little description about what I've done, maybe the steps on how I recreate it, the expected result, the actual result. And if I'm feeling really good and generous that day, I might throw in some logs and some screenshots, right? So this bug, though, was like writing a paper because there was no expected result that I could write in one line. I had to write up everything that I'd done, how I trained it, why my expectation was what it was, and then the actual result. So this was very long. It took me about 2 good hours to write this bug up. Very detailed, beautiful bug, but I felt good about it. The highest severity, right? Because it's not learning. So I opened the bug, submitted it, and guess what happened? The developer, resident expert, closed my bug. I couldn't believe it, and you won't believe what he said. This guy said, well, it works on my machine. So I felt bad again. Okay, I'd done something wrong. So I got over my ego bruise, and I went to him. And I said, okay, great. It works on your machine. How did you set it up? Maybe I did something goofy. And he says, well, and he says, I don't have that exact scenario, but blah, 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 jargon, 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 theory, 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 learning works is essentially what he said. So I said, okay, it'd been a long day. I went home, could barely sleep that night for thinking about this bug, right? It was bothering me. What did I do wrong? I said, that's okay. I'll go in tomorrow, fresh mind, fresh eyes. So I went in the next day. Looked at my setup again, going over it and over it, looking at my code, deleting models, running again, yada, yada, yada. I couldn't find what was goofy there. Called my team lead over, and I said, hey, can you look at this? You know, I don't really know much about this machine learning stuff. And he said, stop it. You've done the research, you've done the coding, you know this stuff. Your setup is fine. I said, okay. I reopened the bug. So the developer, of course, he got annoyed by this, and he wrote in the comments about yada, 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 blah, 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 theory, 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 learning works in the comments, right? But I refused to close it. I left the bug open. So the bug sat there for weeks without being looked at. And then finally, it came time to ship this thing. Well, we couldn't ship with the highest severity defect open, so the product owner called a meeting. So the meeting went something like this. The developer came in, and of course, he's the resident expert, right? He sounds brilliant when he speaks of this stuff. It's really easy to believe that he knows what he's talking about, right? So the guy, he talks about all of the theory stuff and how he knows that learning is working. I took a different approach when I pleaded my case this time. Instead of talking about my setup and my algorithms and my code, I took the stance of being the customer advocate. I said, okay, everything he said sounds wonderful, but at the end of the day, let me tell you what we have here. A customer e-commerce application has purchased us, right? They have a bunch of dudes come in. They are buying these pants like hotcakes. And then when they ask us, what should we show the next guy? We tell them, hey, how about the dress, over and over again. I said, so we are causing our customer to lose money. That's my argument. Do as you will. So when I said this, now all of a sudden, ears perked up. Okay, got it, right? So they said, hey, resident expert, run her scenario just like she has it on your machine. He says, all right, da-da-da-da-da. He runs it. Guess what? It doesn't work. So his face turns red, and he says, I don't know why I doubted Angie in the first place. And that felt pretty good. So what did I learn? I learned that as technology advances, so must our test approaches. So there's a lot of things that, as developers, as test professionals, that we've learned about testing that may not be applicable to the new eras of testing this stuff. For example, we would shy away from things that were not exact outcomes. That has to change when we look at things in technology such as machine learning. There could be others as well. I also learned that the need for automation became much more apparent. So in the testing community, there's a big debate and kind of a battle between, do we really need automation? Do testers need to know how to automate? Who should be doing automation? Yada, yada, yada. I don't have the answers to all of that. What I know is, in my experience, I could not have done this by hand. The thousands of web service calls that I needed to make, I don't want to do 2,000 of those by hand. It was much easier to do this programmatically, right? The data structures that I set up to hold the information about what was happening, I definitely don't want to create Excel spreadsheets and jot this stuff down. So there was this need for automation, and it was much more than just UI automation. So a lot of our testers, they get started with the UI automation, learn Selenium, WebDriver, yada, 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 but you can't stop there. There was no UI in this situation. I had to do serious programming. The web service calls, the logic, the conditional structures, the data structures, all of this stuff became very apparent that I needed to use this. However, there was still a need for testing, for critical and thoughtful testing. I see a lot of companies make the mistake of, oh, we'll get rid of all of our testers and we'll have our devs do this work. Now, resident expert, he can code. He knows machine learning, and yet he was ready to ship this thing without the most simplest of scenarios working. So we definitely need people who are focused on this discipline. And then finally, plain old common sense can still trump an algorithm. My POX method, my go-to, right? So no matter what people say about how advanced technology has become, I don't buy that it's ever advanced enough that it doesn't need testing. I don't know about you all, but I watch the news, and I see lots of errors and failures when we're using this technology. And so we have to make sure that we're not discounting testing. Now, I went to OSCON last year, and there was this amazing speaker, Paul Fenwick, and he talked about the ethics of self-driving cars. And there was a section in his talk where he described the trolley problem. And he did so beautifully. I'm not going to try to do it, so I brought Paul with me to talk about it.
As you all know, for anyone who has read anything about autonomous vehicles or spoken about autonomous vehicles, it is required by law that if you are going to give a talk about one of these things, you have to mention this thing called the trolley problem. So I'm going to get that out of the way right at the start. So I want you to imagine that autonomous vehicles are real. And it's really interesting because 2 years ago when I gave this talk, people were like, oh yeah, they might happen, they might not. People would keep telling me that autonomous vehicles would be a long time coming. Now we're starting to see them on the actual roads. So I want you to think that forward into the future. Imagine that you have really smart autonomous vehicles and you have this situation. You have a cliff face with a single lane that's been carved out of it, and you have a car with an occupant, there are no longer any drivers, who is in that vehicle driving along the cliff face. And there's no place to swerve, there's only one single lane. And quite unexpectedly, a child runs out into the middle of the road chasing a ball and trips. And the car is driving at such a speed that it is unable to stop in time to avoid a fatal collision. Now, if you're wondering how could this possibly happen, the child forgot to carry their personal tracking device, so the car was not aware that they were around the corner, and they were hiding behind some sort of terrain. They were behind a rock or behind a tree. The car did not see them. So the car is going to hit this child. The child will die if that happens. But the car has a choice. Rather than hitting the child, it could choose to throw itself off the cliff. And it's a long, long way down. It would be sacrificing itself and its occupants to save the life of the child. And of course, the question is, should it do this? And some people will say, yes, it should, and some people will say, no, it shouldn't, and lots of people will say, oh gosh, that's a really hard question. How about we talk about something else? That's the most common thing I get, people telling me that, no, this is not possibly something that could ever happen. But let's pretend there is a child there, and you might say, maybe not. But what if there are 2 children in front of the car? Or what if there are 5 children in front of the car? I would hope at some point there is a sufficiently large number of children's lives at risk that you'll say, yes, the car should throw itself off the cliff. It should sacrifice itself and its occupant. So this is like the standard introduction to machine ethics, trying to convince machines to act in an ethical way. And I find this particularly interesting because we can't agree with what human ethics should look like. I have these interesting questions as to, how we should act and what is actually considered to be good. And trying to talk about a machine in this sense is really interesting.
So, of course, my question to you is, how would you test this? Not in production. So what's really interesting, testers, one of our responsibilities is to understand what it is that we're intending to deliver versus what it is that we're actually about to deliver. Find the discrepancies between the two. And one way we do that, one way we understand what it is we're intending to build is by asking questions. So as we dabble into these more advanced spaces like machine learning and AI, those questions might need to get a bit tougher. For example, hey, who are we killing? We might have to ask that, right? And have discussions as a team to decide what do we do in these certain situations and come to a consensus. Now, let me make this scenario a bit simpler for you. Instead of the children, let's say that the autonomous vehicle is driving and there's a deer in the road or some other animal. Then, who are we killing? Both. All right. Are we killing the animal? You all don't want to say. You're too polite. Okay. I'm going to go with the team's consensus was that we kill the animal and save the human lives over animal lives, right? All right. That sounds good, except there are things like this that happen, where Google's photo recognition actually identified and misclassified black people as gorillas. Now, this sounds like a cultural taboo, and folks laugh, except when we look at the situation we just talked about with the trolley problem. And we have black pedestrians who are walking across the road. Now, all of a sudden, they're being killed. And that's not what we want, right? We don't want dead black people in the street, right? So, I don't work for Google. I don't know what happened here, but my guess is that their training system was not diverse enough, right? So there were probably not enough pictures of people with dark skin, so it didn't recognize that, hey, yeah, humans can actually have dark skin, right? So there's a lot of different areas we can focus on with this in testing of machine learning and AI. There's the functional pieces I talked about earlier. There's ethics, there's security, there's privacy, bias, all sorts of things. I don't care which area you go in. Choose one. Pick your poison. I just beg of you to please don't dismiss it as something that doesn't need testers' input. Okay? I'm looking at the state of the world, and machine learning is here. AI is ever growing with or without testing. I'm terrified to think of an AI-driven world without testers' input. So, my friends, the future is here. I beg of you to test it. Thank you.